All right, guys, we're going back to exponents. So at the top of your notebook or paper, I want you to write down exponent review or exponent properties, whatever you prefer. So we're going back to exponents. And you should remember most or all of this. I think at least. We'll see how this goes. Okay, so I'm taking the gold packet videos and I'm going to condense them into about 15 or 20 minutes of giving you guys the very simple rules, which can I borrow this for a second, on Amanda's paper. This was in the gold packet. This chart condensed all the rules for you. This is a part of geometry next year. You'll see exponents, definitely algebra 2. So I just want to make sure you guys are really good with these before you leave algebra 1. Okay, so I want you to write down number 1, just like I have up here. I kept these really simple. When you are multiplying the same base, what do we do with exponents? So I just have multiply same base and then blank exponents. Maggie? Awesome. So multiply same base, I want you guys to write down add in capital letters or real big, underline it, add exponents. This is something you cannot forget from Algebra 1. So multiply same base, add exponents. So underneath that, I want you to write down, we're just going to write down a basic example. So if we have x times x to the third times x to the fourth, what is the answer to that? Jake? Good job. How did you get that extra 1? Where'd that come from? Awesome. There's really a 1 here. So 1 plus 3 plus 4 is 8. Rewrite the base, add the exponents. So multiply same base, add exponents. Did you guys remember that one? Okay. All right, rule number 2. Divide same base, blank. So write down number 2 on your paper. Divide same base, and then a line or a blank, however you want to organize your notes. So what do we do? Dividing same base. What do we do with exponents? You're all saying it. Subtract. So you're going to write down subtract exponents. Divide same base. Leave the base the same. Leave the base alone. Subtract exponents. For example, let's say we have 4 to the 8th over 4 to the 3rd. So we're dividing same base. We're going to subtract exponents. In exponential form, what is the answer to that? Will? Good. 4 to the 5th. Rewrite the base. Subtract your exponents. X minus 3 is 5. Jake. It is. I shouldn't shake my head. No, that is. But this is 4 to the 8th divided by 4 to the 3rd, Jake. 4 to the 8th is not 4. It's 4 times 4 times 4 times 4, etc. So very, very different. That's why when you're dividing same base, rewrite the base, subtract the exponents. Okay? Good question, though. All right, number 3. Anything to the 0 power. So if you have a 0 exponent, so rule number 3. These rules apply in any math class you're taking because your exponent rules are not going to change. Yeah, the problems could become difficult, but there's always these basic rules that you can follow. Always. Zach, anything to the 0 power is? Nope. Nope. Haley L, anything to the 0 power? Say that again. 1. Anything to the 0 power equals 1. Your calculator is smart enough to tell you that, so if you forget that for some reason, you could type that into your calculator, hit enter, and it will tell you that anything to the 0 power is 1. All right, so what do I mean by that? I have 2 examples here. I'm going to give you 2 because one of them is a little tricky. So let's just say we have 2x squared all raised to the 0 power. So 2x squared all raised to the 0 power. Travis, what's that equal to? Two x squared all to the 0 power. The whole thing is 1. Everything in parentheses is raised to the 0 power, so that entire answer is 1. Okay, second example for this one is 4 to the 0 times x to the third. 4 to the 0 times x to the third. Well, good. How'd you get that? Good job. 4 to the 0 power is 1, and then you're left with x to the third. 1 times x to the third is just x to the third. So anything to the 0 power is 1, but just be careful. They might make one term to the 0 power and not everything. So take your time on that. Okay, rule number 4. We have 2 more here. Negative exponents, and then you can put a line. I just put a box. If you have negative exponents, of course you are not allowed to keep them in your answer. So do you guys remember what we did? If you have negative exponents, how do we make them positive? Well, good. Move them to the bottom of the top. So I always told you guys flip them to the opposite side. So if they're on the bottom, move them to the top. If they're on the top, move them to the bottom. Do not leave your answer with negative exponents. You need to flip them. So move them to either the top or the bottom. That's up to you, depending on what the problem is. Okay, let's say we have 4x to the negative 6th power. So here's your example. 4x to the negative 6th power. What are we moving here? So what moves? Sage, what moves? Okay. Dirk, what do you think moves? Okay, Dirk, why not 4? Good job. It's really 4 times x to the negative 6. The only thing we're moving is x to the negative 6. This gets moved to the bottom. The 4 stays where it is. It's really to the first power. So your answer is going to be 4 over x to the 6th power. Don't move the 4 because it's to the positive first power. That is your answer. Sage, does that make sense? You all right? Are you tired? Okay. Any questions on that part? Okay, one more, then we're going to do some examples together. Exponent raised to an exponent. So last rule, it's called the power of a power rule, but we can write it as if you have an exponent raised to an exponent. So what do? Exponent raised to an exponent, Travis. Good job. Multiply them. So I'm just going to write down multiply. So an exponent raised to an exponent, you multiply them. It's also known as the power of a power rule. Multiply them. And again, these are very, very beneficial rules for you in your high school math classes you guys will see in the next couple years. So let's say we have 2 to the 3rd x, y to the 4th, all raised to the 2nd power. So looks difficult, but it's not. 2 cubed x, y to the 4th, all raised to the 2nd power. This is an exponent raised to an exponent. It's a power of a power rule. So all you're doing here, I would say put a 1 where the x is, and we're distributing the 2 to every term inside parentheses. Leave your answer in exponential form. What would the answer be? So leave it in exponential form. Heather? Why did the... Oh, good, I just didn't hear you. Awesome. So multiply your exponents. You get 2 to the 6th, x squared, y to the 8th. That's it. Okay, those are the rules. Did you guys honestly remember those? Yeah? Okay. All right, we're going to do a couple other examples after I give you the steps here, and then I'll give you like 15 or 20 minutes to work on some exponent practice problems that you should be able to finish. So underneath those 5 rules, I want you to write down these 3 steps, okay? What are these steps used for? These are the steps that I told you a couple months ago are used as an order of operations for exponents. So this is our order of operations for exponents. The first thing you always need to do is simplify what is in the parentheses or get rid of the parentheses. Second thing you need to do is get rid of the negative exponents. And then the third thing you need to do is simplify everything using those rules. So step 1, get rid of the parentheses. Step 2, get rid of your negative exponents. And then step 3, just simplify everything using the rules that we just went over. If you know those and know those 5 steps, you could have a huge exponent problem and be able to complete it correctly. These don't get much harder, they're just going to make the problems longer. Okay, we're going to do a couple examples until I feel like you guys are all right. Okay, don't worry about writing this down. This is from a different worksheet. All right, so practice problems, and I'm going to call this number 1. So underneath that, if you want to write down practice problems or examples, we're just going to go through a couple of these because some of these I did not address as a basic example when we went through the roles. So practice problems number 1. All right, so negative 8m to the 4th times 4m to the 8th. Here's where some of you guys got confused. What do we do with that negative 8 and the 4, the coefficients there? Matt, what do you think we do with that negative 8 and the 4? No idea? Amy, any idea? Good, multiply them. So first thing you need to do is multiply the coefficients. Remember, if the coefficients, which are the numbers in front, if they don't have an exponent, multiply them. They're different numbers, they don't have an exponent, multiply them together like we normally would. Rena, what do we do with the m's? Good. When you multiply same base, add exponents. Rewrite the m, add the exponents. Your answer to example 1 is negative 32 m to the 12th. Questions on that one? Okay, second one. So example number 2. This should be an easy one. A to the 3rd times a. When you multiply same base, Sam, what do we do with exponents? Add them. So Melissa, what's the answer to this one? Good. 3 plus 1 is 4. So that one should be very, very basic. You just get a to the 4th. Okay, number 3. This one's a little bit harder. So example 3. All right, 3p to the negative 15th and then 6p to the 11th. They're both in parentheses, so we're multiplying them. Okay, first thing we need to do is multiply the coefficients. So 3 times 6, get rid of our parentheses, is 18. Now, there's 2 things you can do here. We can rewrite the p to the negative 15th and p to the 11th, or what else could we do? Will? Good job. So let me rewrite them just in case you guys need to. And as Will said, after you multiply the coefficients, we need to move that negative exponent. Remember, try to get rid of parentheses first, get rid of negative exponents, and then simplify. Move or flip your negative exponents to make them positive. So p to the negative 15th moves to the bottom. So we have 18p to the 11th over p to the positive 15th power. Okay, Helene, when we divide same base, what do we do with exponents? Good, we subtract them. So our next step is to subtract. So we have 18p to the 11 minus 15 is negative 4. Remember, when you subtract exponents, always leave them in the numerator. And then our last step is going to be what our answer is. So I would keep a 1 underneath this. Move p to the negative 4th to the denominator. So our answer is 18 over p to the 4th. Jake. Go ahead. That's fine. That's fine. Yep. Some of these problems, you can do them either in condensed steps, you can do them differently. And I was going to ask you guys that, then I didn't want to confuse you. But yes, if you multiply same base, you can add exponents instead of moving the negative first. It's completely up to you. Either way. Any other questions or comments? Okay, let's try a couple more. Okay, what number was that? Number 4 that we're doing is 1 over b to the -7 times b to the 5th. So 1 over b to the -7 times b to the 5th. There are not any parentheses to get rid of, so go to step 2, which is get rid of the negative. First thing you should do is take b to the -7th, move it to the numerator, make it positive. So we have b to the 7th over b to the 5th. Okay, and then Zach, when you're dividing same base, what do we do with exponents? Good, subtract them. So 7 minus 5 is 2. You get b to the 2nd. All right, give me a thumbs up, thumbs middle, thumbs down. How do you feel about those? Okay, any questions on the ones we've done? Do you guys feel like you're ready to try some on your own, or do you want to try some more? You guys ready for some on your own? Okay. All right, if you have your book, I want you to open it up. If you don't have your book, go ahead and get it, please. Okay. Okay, I want you guys to open up to page 945. Okay, and I want you to do numbers 2 through 40, just the evens. So 945, it's way in the back. 2 through 40, evens. Keep your answers in exponential form. I'm going to walk around to make sure you guys are okay. There's paper back there if you need more. What you don't finish in class is homework. If you need to look at the notes that we did today, please make sure that you do that. So 945, 2 through 40, just the evens. Leave answers in exponential form.